Welcome to this presentation, in which I shall outline the manufacturing process of the frame unit, one of the key components of the Blinking Sail Windmill. This slide shows 4 perforated steel flat bars, one of the essential building components of a frame unit of the Blinking Sail Windmill. To reduce the overall weight of the windmill, composite graphite or strong polymers may be used instead of steel bars. The 2 horizontal bars are 2 meter long, 5 centimeter wide and 5 millimeter thick, while the 2 vertical bars are 1 meter long, 5 centimeter wide and 5 millimeter thick. When the 4 bars are connected together, they will constitute one side or one face of a frame unit. A frame unit may have 1 or 2 sides. In this slide we see 8 bars held together to form one double-sided frame unit. This slide shows an upper steel angle with 10 holes of different sizes. The function of the upper steel angle is to connect together the upper bars of a frame unit. The 4 small holes seen in this slide are used to connect the upper bars by small screws, while 4 of the large holes, 2 in the center and 2 at the upper end of the angle, will be used to connect the frame units together by nuts and bolts. One of the large holes of the upper angle, seen here at the bottom of the slide, is used to connect it to the swinging window shaft, while the remaining hole, also shown at the lower end of the slide, will be used by a hook connected to a steel wire, which is used to connect successive frames. This slide shows a lower steel angle designed to connect the lower bars of a frame unit. A lower steel angle is shorter than an upper steel angle and with less number of holes. In this slide we see 2 upper steel angles and 2 lower steel angles. Note the difference in size and number of holes in both types. In this slide we see key components of a frame unit. Here we see a horizontal bar, 2 meter long, 5 centimeter wide and 5 millimeter thick, and a vertical bar, 1 meter long, 5 centimeter wide and 5 millimeter thick. We also see short and long steel angles, both drawn here in yellow, and 2 purple sail shaft holders. This slide shows how a lower steel angle is connecting together the lower bars of a frame unit. This is a close-up showing how the upper bars of a frame unit are held together by an upper angle. Note the 2 holes at the extended end of the upper steel angle. One hole will be used by the swinging window shaft and the other one by a hook. In this slide we see a double-sided frame unit. 8 flat steel bars held together by 4 steel angles to form one frame unit with 2 sides or 2 faces. This slide shows 2 sail shaft holders. The threaded end will be bolted to one of the holes of the swinging window, while the end hole will be connected to the sail shaft, as we will see soon. This picture shows a mounted bearings. A ball bearing is housed inside a metal casing with 1 hole at each end for connection purposes. This diagram shows a green swinging window, a metal grid designed to prevent the sail from blowing over to the other side. The 2 outer holes are used by the purple sail shaft holders to firmly connect the purple sail shaft, seen here at the top of the slide, to the green swinging window. This slide also shows the 2 purple sail shaft holders at their corresponding positions, as well as in the black margin to the right of the green swinging window. We can also see the purple sail shaft and how it is holding 2 blue mounted bearings. This slide shows how the blue swinging window shaft is attached to an upper steel angle. This slide shows how the blue swinging window shaft is fixed onto the frame unit by 2 upper angles. The 2 yellow mounted bearings are fixed in position by the blue swinging window shaft. The 2 holes of the mounted bearings will be used to connect them to the green swinging window. The swinging window will swing freely since it is connected to two mounted bearings permitting free movement. A spiral spring attached to the mounted bearings will adjust the gap of the swinging window according to the speed of wind. This slide shows how the blue swinging window shaft is attached to an upper steel angle, as well as how the mounted bearings will be held in place by the horizontal rectangular bushing, where the bushing is welded onto the blue shaft. This slide shows how the blue swinging window shaft is connected by an upper angle at each end. The shaft also holds two mounted bearings. In this slide, we see the green swinging window as a metal grid. See how the blue swinging window shaft is connected at both ends by upper steel angles. Furthermore, this slide also shows how the two yellow mounted bearings are connected to the green swinging window. This slide shows a double-sided frame unit, 8 bars held together by 4 steel angles. The slide also shows the positions of the two yellow mounted bearings and how they are fixed onto the green swinging window. Note how the two mounted bearings are fixed onto the blue swinging window shaft and how this shaft is connected to the frame unit at both ends by two upper angles. The green swinging window is shorter in width and height than the flat steel bars by 5 centimeters to allow free swinging. This slide shows a red sail made of either cloth or synthetic materials and a purple sail shaft with two blue mounted bearings above it. The red sail can be made of two thin layers of plastic or rattinge sandwiching a mesh of fine steel wires such as piano wires. The result is a tough yet light sail that can easily be moved by a light breeze. Note the two positions on the sail where the sail shaft will be fixed onto the green swinging window by two purple sail shaft holders, which we saw in a previous slide. The red sail will be fixed onto the blue mounted bearings by using the 4 holes shown in this diagram. This slide shows a double-sided or double-faced frame unit. In this slide we see the green swinging window as a metal grid and how it is fixed onto the blue swinging window shaft. We also see the red sail fixed onto the sail shaft. What is missing in this slide is the purple sail shaft and its two mounted bearings. This slide shows the green swinging window and its blue shaft, which is holding two yellow mounted bearings. This slide shows the red vertical post of the Blinking Sail Windmill. It is 28 meters long and has two red mounted bearings. The two red mounted bearings will be used to hold in position 4 large white frames. Only 2 are seen in this slide. In this diagram we see on each side of the vertical post a complete large frame, each 20 meters wide by 20 meters long, where each frame consists of 200 frame units, each 2 meters wide by 1 meter long. This slide shows a double-sided frame unit 2 meters wide by 1 meter long and how it is connected to the other frame units. This type of a frame unit is the basic building block of frames used in medium and industrial size blinking sail windmills. The slide shows the relationship between individual frame units and how they are connected together. This slide shows how 4 double-sided frame units are connected together. They are part of the frame, which has a dimension of 20 meters wide by 20 meters long. Such a frame will consist of 200 frame units. This slide shows 9 double-sided frame units and how they are connected together. This slide shows 4 double-sided frame units connected together. A small residential windmill may have such a frame, 4 meters wide by 2 meters long. A small size windmill may have a frame made up of 8 double-sided frame units. The frame of such a windmill will be 4 meters wide by 4 meters long. A medium-sized windmill may have a frame made up of 18 frame units with a total dimension of 6 meter wide by 6 meter long, as shown in this diagram. This diagram shows a micro windmill made up of only 4 one-sided frame units. The dimensions of this frame is 4 meter wide by 2 meter long. In medium and industrial-sized windmills, double-sided frame units are used to prevent wobbling and destruction in high altitudes and strong winds. In super micro windmills, one-sided frame units will be used. Here we see a frame 2 meter wide by 2 meter long. This diagram shows an industrial-sized blinking sail windmill. Note the relative size of the windmill to the palm trees in the foreground, as well as the steel wires E anchoring it to concrete blocks D in the ground. This slide shows a blinking sail windmill with 4 spinning frames. The active frame, the one on the right, will prevent the wind from passing through it. This resistance by the active frame will result in a wind-driven blinking sail windmill. The wind passes freely through the other frames. This slide shows a blinking sail windmill with 4 spinning frames. In this slide we see 2 frames. The active frame on the right will block the wind and causes the blinking sail windmill to spin, while the left frame will allow the wind to pass freely through it. As we can see from this presentation, even an industrial-sized blinking sail windmill can easily be manufactured, packed, transported, and quickly assembled at site by unskilled people in a very short period of time.